Let's start with the most basic question of what is a collection. Quite simply, a collection is a type whose purpose is to group data together and let you deal with lots of objects at the same time. Being able to do this is absolutely crucial if you are dealing with almost any kind of real data, because almost all data comes in the form of lots of objects, or instances to use the correct C# term. Lots of customers, lots of employees, lots of sales, lots of controls if you're dealing with a user interface, and so on. Collections are types that are designed to encapsulate a set of related objects together, so that you can treat them as one single collection object on which you can then perform operations such as searching for a particular item of data in the collection, or doing something with every item of data in turn. There are lots of different types of collection in the .NET framework, but in this beginner's level course, I'm going to focus on just three: the array, the list, and the dictionary, and that's because those are arguably the most widely used general-purpose collections. There are lots of more specialized and more advanced collections which will often give you cleaner code or a more efficient solution to a particular problem, but for a very wide range of situations, you can come up with a reasonable solution using either the array, the list, or the dictionary, which is why I think those are the most appropriate collections to start you off with. So, let's get started with the array. The two particular characteristics of an array are that it contains a fixed number of items in a definite order. As an example, imagine that for some reason we need to store the days of the week. There are 7 days, and there will always be 7 days. That's the fixed size. And the days also have a specific order. Tuesday always comes after Monday, Wednesday always comes after Tuesday, and so on. And for the first code demo, I'll use the days of the week as an example to show how to instantiate an array and display all the items in it. So I'm in Visual Studio with a freshly created console app. If I wanted a single string, I'd do something like this: string Monday equals, and then initialize it with the text I want. But I've said we want all of the days of the week, so that's 7 strings, so we need a collection of strings. I'll paste in the code we need. This is it. Let's analyze this. I'm declaring the type as string followed by square brackets. Those square brackets are crucial. They are what tells the compiler that this is not a single string, but an array of strings, or of whatever type is in front of the square brackets. To initialize the array, you can see that I've listed out all the 7 strings that will go in it, separated by commas. And I've got curly braces around the whole set of strings. And because this whole thing is one single C# statement, there's a semicolon at the end. There are other ways to initialize an array, which I'll cover in the next module. But this is the simplest way if you know upfront what data will go in the array. So that will do us for now. A very common task with collections is that you need to do something with every item in a collection in turn. An example with this array would be if you need to list all the days of the week in order. So let me show you that. I'll just get rid of this single string as we don't need that now, and I'll paste in the code to display all the days. I'm using a for each loop. That's the simplest way to iterate through every item in a collection. I'm literally saying for each string day in days of week, and then we have some instructions in squiggly braces. What's going to happen is that the code will take each item in the array in turn. It'll set this variable day to equal that item, and then it will execute whatever is in the loop. That is, whatever statement or statement block comes straight after the for each using that item. So in our case, the loop will execute once with day equal to Monday, the first item in the array. Then it'll execute with day equal to the second item in the array, Tuesday, and so on until it's gone through everything in the array. In this case, what is in the loop is simply a command to write out the item to the console. But obviously, you can put whatever code you want there to process the item in, well, however you want. It doesn't have to involve displaying the items. I'll compile and run that, and you can see that what is being displayed is each item in the array. The strings Monday, Tuesday, Wednesday, and so on. And do notice the items were displayed in exactly the same order that I listed them in the code that initialized the array. And that brings us back to this thing that arrays are ordered. This statement initializing the array listed the strings in a definite order, starting with Monday and finishing with Sunday. And that is exactly the order in which the items will be stored in the array. And when the for each loop comes along and asks the array to supply each item that it contains, the array supplies those strings once again in the exact same order. You can see this if I change the order. I'll just edit this code and put Tuesday before Monday. So now Tuesday is the first day in this array, and I will run the code again. And you see the app has now listed the days of the week with Tuesday first, keeping the order that I initially specified the days in. Having Tuesday first is a bit weird, so let's change that back to the correct order for the days. One other thing, here I'm demonstrating an array of strings, but I should emphasize that you can make an array of literally any type. This code declares an array event. This declares an array of system.drawing.point instances, and so on. And the for each loop works the same way no matter what type is in the collection. The point of collections is to group data together, and they work the same way whatever type of data you put in them. While I'm here, I should clarify some terminology. You'll generally refer to each object in the collection as either an element of the collection or, more informally, as an item in the collection. Personally, I prefer to call them items, but I'll use both terms interchangeably in this course, so you get used to hearing them both. And the thing we did in the for each loop, of going through every element in the collection in turn, the correct terminology for that is enumerating the collection. Although you'll often also hear people talk of iterating through the collection. Another very common task is to pick out an individual item in a collection, or to use the correct terminology, to look up an item. And I'll demonstrate this with a sample that lets the user ask for a day by number. For example, the first day of the week is Monday, so if the user types in 1, the app will display Monday. If the user types in 2, the app displays Tuesday, the second day of the week, and so on. I've called this sample nth day for reasons that I hope are obvious. And this is my first stab at writing the code for the app. Once again, you can see the days of week array that contains the names of all the days. The first thing the app does is read whatever the user types in using this console.readLine. Console.readLine always returns a string containing the text of what the user has typed in, so we convert that to an integer. For simplicity here, I'm not doing any error checking, I'm just trusting that the user really did type in an integer. And I store it in a variable which I'm calling iDay for reasons that I'll explain soon. And now comes the interesting bit. How do I display the correct day? And the answer is this code. I create a variable called chosenDay, and I set it equal to days of week, square brackets, iDay. And this is a fundamental thing for all collections. When you want to look up an item in the collection, you do it by putting square brackets after the collection variable. Square brackets basically means get this item from the collection. And then, inside the square brackets, is some information that tells the computer which item you want. For arrays, you always specify the item using a number. And the reason for that goes back to this thing that arrays are ordered. So arrays very specifically have a first element, then a second element, and a third element, and so on. That's how arrays work for lookup. You supply a number which says which element in order you want. And this number, by the way, is called the index. And that's why I gave this variable the name iDay. This variable stores the index of the day. And I just used I to stand for index, which is a very common historical convention in programming. Let's see if the code works. It's asking me which day I want, and let's start really simple and say I want the first day, so I type in 1. And, oh dear, that doesn't look right. It's telling me the first day is Tuesday. What's gone wrong? Well, what has gone wrong is that arrays are what is known as zero-indexed. As human beings, when we see lists of things, we automatically think of the first item as number 1 and the second as number 2, and so on. In other words, we start numbering with 1. Arrays in C# do not normally work like that. As far as C# arrays are concerned, the first element is number 0, or more correctly, has index 0, and then the second element has index 1, and so on. That's what I mean by zero-indexed. If you were being alert, by the way, you may have noticed that the icon I'm using for arrays shows zero-indexing. I deliberately designed the collection icons for this course so that they represent aspects of how each collection works, because I think that's a good mnemonic for you. The padlock, by the way, represents the fixed size. Anyway, with this knowledge, the output from our app makes perfect sense. I typed in the number 1, and with zero indexing, 1 means the second element, which is obviously Tuesday. So if I really want the first element, I have to type in 0. Let's do that. Run the code. 0, And now it has correctly displayed Monday. What if I want the last element of the array? Let's think about this. There are 7 days, so you might think that the last element would be number 7. But remember, we are zero indexing. Looking at the numbers on the slide, you can see that the last element is actually number 6. Let's check that. Type in 6. And yes, the program has displayed Sunday, which is the last day in our array. So that logic works fine. And this is a really important general rule with zero-indexed arrays. The index of the last element is always 1 less than the number of elements in the array. This days of week array has 7 elements, and that means the last element has index 6, not 7. Just out of interest, I wonder what would happen if I did ask for the element with index 7. Let's see. Run the program. I'll type 7 and, oh, it's crashed. It's thrown an exception. Index was outside the bounds of the array, which makes sense because there is no element with index 7 in this array. And this is another really important point with arrays, and in fact with all Microsoft collections, not just arrays. They are designed to be very safe and will very quickly stop you from looking up things incorrectly. If you try and look up an element that doesn't exist, any Microsoft supplied collection will immediately throw an exception. So now we understand the zero-based indexing. But this app isn't really very intuitive, is it? If a user wants to see the first day, what are they going to type in? Well, let's face it, out in the real world, almost no one is going to think that the first item must be item 0. I could reword the prompt that the app displays to make it clear to the user that we're using zero indexing. But really, I would say having any UI that presumes zero indexing is a very bad design choice. It'll be far better if we allow the user to use the one-based indexing that everyone is familiar with. How do we do that? Easy! We just subtract 1 from whatever the user typed in. There. Let's run that. I'll say 3 for the third item, and that looks fine. We can now look up items in a way that's intuitive to users. So, why do arrays use zero-based indexing? If you are new to collections, zero indexing might seem like a really stupid thing to do because it's so unintuitive. But there are historically good reasons for it. Basically, back in the old days, when people had to manage memory a lot more explicitly than you would today, having arrays zero-indexed actually made memory management easier. And it also made collections work a bit quicker at a time when computers were slow, and you really did need to worry about optimizing all your code for speed and so on. And now, because of that history, that's just how it works, and we have to accept it. So far, I've shown you 2 different ways to read data that is in the array: enumerating all elements and looking up individual elements. Now it's time to try modifying the array. Specifically, the next demo will demonstrate how to replace items in an array. So I've gone back to our earlier example of the code that enumerates all the days of the week, And to change our example a little bit, let's assume that our array has got a mistake in it. Oopsie! That's not how you spell Wednesday, is it? Let's see how we can fix this using C# code. I'll type in the code to replace that element. Days of week 2 equals Wednesday, spelt correctly. So what we see here is once again the use of the square brackets to identify a particular element by index. And of course, it's a 0-based index, so Wednesday is day 2. The only difference from before is that now this square bracket syntax is on the left-hand side of an assignment operator. And this shows that the exact same square bracket syntax works both to look up items in an array and to identify an item to be replaced. Just to verify that this code works, I'm going to paste in another for each loop so that we can see the elements all enumerated both before and after the fix. And just to make the code shorter, I'll remove these squiggly braces. As you're probably aware, with loops in C#, you only actually need the braces if there is more than one statement in the loop. But in this case, both loops have only one statement, the console.writeLine. I'll also add a couple more console.writelines outside the loops, just to make the output a bit clearer. Let's run that. And you can see that has worked perfectly. The before state has Wednesday spelled wrong, and the after state has it spelled correctly. So that's how you replace items in an array. Now I want to talk a bit about debugging with arrays. You see, there's another way I could have confirmed this code was working without the extra console.writelines. I could have just stopped this code in the debugger and inspected the array. Let's do that. So I'll put a breakpoint just after I initialize the array, and this time I will run the code in the debugger. So it's stopped at the breakpoint, and the real reason I'm doing this is that I want to show you just how amazingly nicely collections play with the debugger. I'll hover the mouse over days of week so I can see the value. The displayed value simply says string 7, meaning an array of 7 strings, and there's an arrow inviting me to expand it. If I hover over the arrow, the user interface expands to show me each of the elements. And notice the debugger also uses the square brackets notation to indicate indexing into an array. And you can see it's 0 indexing too. The first item, Monday, is item 0. The takeaway here is that using collections with the debugger is really easy and intuitive. We're almost at the end of the module, and I've shown you a lot about arrays. But actually, you've learned more than you might think, because almost everything I've shown you about arrays is true for most other collections too. The square brackets to identify an element of an array, using the for each loop to enumerate every item in an array, the 0-based indexing, the seamless integration with the debugger. Those ideas aren't only for arrays. The same principles and roughly the same syntax work for collections in general, including the list and the dictionary that you'll be learning about later in this course. And that's great, because it really aids working with collections. Whenever you meet a new collection, you can just reuse the same syntax that you're already familiar with. So, in this module, I've hopefully given you a good introduction to collections, focusing on arrays. I'll just quickly recap. You've learned that collections are types that group multiple objects together. You can use a for-each loop to enumerate all items in a collection, and you normally use a square bracket syntax to identify items in a collection, whether to read or write to them. But when using the square bracket syntax, you must use zero-based indexing. And you've also seen that collections integrate very seamlessly into the debugger. In this module, I've exclusively used very short code snippets to show you the principles of coding with arrays. Next up, you're going to start seeing arrays used in a slightly more realistic scenario as I start to develop the main demo code for the course. Hello! This is the Plural Site course Beginning C# Collections. I'm Simon Robinson, and in this module I'm going to introduce a sample demo and show you how you can read data from an external data source into an array. In particular, as I develop the demo, you'll learn how to instantiate and populate an array when you don't know upfront what data will go in it. I'll show you how, if you don't explicitly initialize an array, it still starts life full of data, but for reference types, that data is all nulls. And the code will reveal how ubiquitous arrays are, because we'll start stumbling over them in a couple of places where we weren't even intending to. In this course, the theme of the demo app is countries. I'm going to write a sample that shows population data for the countries of the world. The data is sourced from an external data file, actually a CSV file, and the code will therefore need to read this file into a collection in order for the app to make use of and display the data. To start off with in this module, the app is simply going to list the top 10 most populated countries of the world in order of decreasing population. So that's what the demo will do. Let's get started. I've created the sample demo as a console app. I'm using console apps throughout this course just to keep things as simple as possible and avoid having to write lots of UI code that isn't really relevant to what I want to teach you about collections. The app contains 4 main types. The main program that runs the overall program logic, a class that represents a single country, a class called CSV Reader, which is responsible for importing the countries from the CSV data source and populating the array of countries from it. And this last class, Population Formatter, which I'll talk about later. I'll start by showing you the country class that represents a country. There's nothing really unusual going on here. It contains read-only properties for the country name, code and region as strings, and the population as an integer. The constructor requires you to supply all this information at construction time, so this class is essentially a read-only bag of properties. Now for the CSV Reader class that will handle reading the CSV file. It contains a field that tells it the path of the CSV data source, and a constructor that expects that file path. And then there's a method called readFirstEnCountries. This will be the method that imports the countries from the file. It takes as a parameter an integer that tells it how many countries to read. And you can see it returns an array of country. But I haven't yet completed this method. For now, it's just a dummy method that returns null. And having this method return null shows up an important point about arrays. For all their unique syntax with the square brackets, arrays are completely normal reference types. You can treat them just like any other reference type. You can set them to null, and you can return them from functions. Now let's examine the program's main method, which controls the overall logic. The first thing the code does is set the file path of the CSV data source and instantiate a CSV reader. To keep things simple, I've hard-coded the file path to the location of the file on my system. Obviously, if you download and try out the code, you'll need to change it to reflect whichever folder you download it to. Then I declare the array of countries and instantiate it by setting it equal to whatever the readFirstEndCountries method returns. I'm passing 10 to the method because, surprise surprise, I want 10 countries. Then you have a for each loop, just like you saw in the previous module, to display the countries. Here I'm only displaying the country's population and name. If I run this now, it's not going to work. Null reference exception, and that's at the point where we start to enumerate through the array of countries. The reason for this is that, remember, I had readFirstEndCountries return null. So the variable countries is null when we enter the loop. And you can't enumerate null. The variable you're enumerating in a for each loop has to actually contain something that you can, in principle, iterate through. So we need to start implementing readFirstEndCountries properly. In the previous module, I instantiated a days of week array by explicitly providing all the values to go in it. The format with squiggly braces, by the way, is called a collection initializer. But explicitly supplying values up front is not possible here, because there's no way to know the values at the time the array is created. The app needs to put the countries in the array as it reads them in from the CSV file. So I'm going to do this instead. Array of countries equals new country, square brackets 10, and return that. The number 10 tells .NET how many values need to go in the array, but I don't say what those values will be. 10 because the app will read in and display the 10 most populous countries. And in general, that is how you instantiate an array if you don't yet have the values to go in it. The format is quite similar to instantiating a non-collection type. New, then the name of the type. But notice the array size goes in square brackets, not the round brackets that you'd usually use when invoking a constructor. And you must supply a size, by the way. If I don't tell the compiler how big the array will be, that's a compilation error. Look. Array creation must have an array size or array initializer. That's because the .NET framework simply can't instantiate an array without knowing how many items it will store. So I'll put the number back. But in fact, saying 10 here isn't quite the best way of doing this. We already have the number of countries supplied in this endCountries parameter. So rather than hard coding the 10 again, I should really just use that variable. And that tells us that the size of the array doesn't have to be a compile time constant. It can be something that's only known at runtime, but it must be there. So what does countries contain at this point? I'll show you in the debugger. I'll set a breakpoint just after we've instantiated countries and run in the debugger. It's stopped, and I'll hover the cursor over countries and expand. And you can see it's an array with 10 countries in it, but every country is null. And that makes sense because I've told the compiler that I want an array of 10 countries, but I haven't initialized any of those countries. And that's an important principle with arrays. When you instantiate them, they always start their lives full of values. But if you don't explicitly initialize those values, all the values will be uninitialized. So null for a reference type, and zeros if it's a value type like int. Next up, I need to write the code to import the data from the external CSV file into the array. And this is the file the code needs to read. The first line is just a header line. After that, each line contains the data for one country. And within each line, there are 4 items of data about that country, separated by commas. Or, if you prefer, 4 columns. These are the name of each country, a 3-letter code for each country, the region, that is the broad geographical area or continent that the country is in, and the population in 2017 of that country. A word of explanation, by the way, just in case you're not familiar with CSV files. CSV stands for comma separated value and literally means what you can see in this file, a text file in which the values are listed separated by commas. It's a common format that's particularly associated with spreadsheets and, by the way, is fully supported by Excel. And it's brilliant for saving spreadsheet data as pure text. Conveniently, this file already lists the countries in order of decreasing population. That makes our task of displaying the top 10 countries by population very easy, because it means we just need to read in the first 10 countries in the file, and we can ignore everything beyond those first 10 countries. By the way, if you're wondering where I got the data from, most of the data is from the World Bank. The code download for this course contains a text file that gives more details of exactly how I sourced the data, as well as the CSV data source itself, and of course the actual code. Since each line of the CSV file contains data for a single country, an obvious step in importing the data file is going to be converting a single line from the file into a single country instance. I've written a method to do that, and I'll just go back to Visual Studio and paste it in. It's called read country from CSV line. It takes as an argument a string which will be the contents of a line of the file, and it returns a country instance that we've hopefully parsed out from the line. So what's the logic here? Well, recall that each line of the CSV file contains the country name, code, region and population, all separated by commas. So this method needs to split the string it's been passed wherever it contains a comma, so that we get 4 separate strings representing the parameters that the country constructor requires. And that's exactly what this method string.split does. It's a method on string that Microsoft has provided to split up strings, and it suits our purposes perfectly here. I'm passing what looks like a single comma character as an argument. The argument tells split which character is going to be the delimiter, that is, the character that separates out the fields. The delimiter is a comma in this instance, but in a different scenario it might be the tab character or a semicolon and so on. Split will split up the string wherever it sees a delimiter character and return the result. But here's the interesting thing. Look at what it returns, an array of string. You see, string.split takes one big string and returns potentially lots of smaller strings. How else can it return lots of strings other than in a collection? I told you that collections are everywhere, didn't I? Now it's easy. The array returned by string.split will contain the 4 strings corresponding to each of the columns in each CSV line. The first part is going to be the name, the second will be the code, the third the region, and the fourth will be the population. And of course, I access this data using the square bracket syntax and remembering that the array will be 0 indexed. I need to convert the population to an integer, and to be safe, I'm using int.parse, which will throw an exception if for any reason the final field can't be parsed as an int. Simple, huh? Well, actually, this code is too simple. If I look down at the CSV file, there are complications. Egypt here has quotes around its name, and that's because there's a comma in the name itself. The CSV file format puts quotes around data that contains commas so that any software reading the file knows that those commas are part of the data and not delimiters. The code I've just written won't be able to cope with that. String.split will see that comma and split the name of Egypt in two, and then everything will go wrong. But don't tell anyone. I'm going to cheat for now and leave the code as it is. You see, I know Egypt isn't in the first 10 countries in the file, and we're only reading the top 10, so we won't hit this problem of embedded commas in the data just yet. I'll deal with it in the next module. By the way, I mentioned how string.split returns an array, and I pointed out that illustrates how widely used arrays are. But I should also point out that there's actually a second array hidden in this code. If I hover the mouse over the split method, look at the method signature. This method doesn't take a char as a parameter. It takes an array of char. The reason I got away with just apparently passing in a single comma as the argument is that in the method signature, that argument is marked with the params keyword. Params provides a bit of syntactic sugar in C# that allows you to just provide individual values to a method that would usually expect an array and have the compiler build the array under the hood for you. So I could more correctly have written the parameter as an array containing a single char, like this. New char and provide the value using the usual collection initializer syntax. It makes no difference because that's what the compiler will turn this code into anyway if I don't write the array explicitly. Params isn't something you'll meet too often, so it's not something to worry about at this stage in learning about collections, but it does give another indication of how widely used arrays are in .NET. So we can now read one CSV line OK. The next step is to combine that to read all the countries that we need. I'll go back to the read first end countries method and just paste in the code we want. I first instantiate a stream reader, which is the type Microsoft provides to read text files. That's in the system.io namespace. I need to tell the stream reader the path of the file to read, which recall is stored in the CSV file path field. StreamReader has a method called readLine, which reads the next line of text from the file and returns what it's read as a string. Remember, the first line of our CSV file is the header line, which we can ignore. So I just call readLine, but I don't do anything with the result. Then I have a for loop to read however many countries we've been told to read via the nCountries parameter. For loops are great ways to populate arrays that you've instantiated with uninitialized data. Each time round the loop, I grab the next line of the file using streamreader.readLine, and then I pass that line to the readCountry from CSV line method that I've just written to parse the line into a country instance. And now, the important bit for learning about collections. I set the ith element of the country's array to the new country instance that read country from CSV line has returned. Remember from the last module that square brackets in front of an equal sign is how you replace an element of a collection. Before we execute this loop, countries is an array containing all nulls. This loop progressively replaces every null with the next country read in from the file. Also, notice how the for loop starts at 0, not 1, because arrays are 0 indexed, so the elements in the countries array are numbered 0 to 9, not 1 to 10. And lastly, the whole loop is inside a using statement. That's required by StreamReader and makes sure that the StreamReader object is disposed of once we've finished with it. That's important because stream readers actually lock the file they're reading, and disposing the stream reader will unlock the file so other processes can use it. And that's it. The code is now complete and I can run it. Ooh, is it going to work? The tension. Yes, it's worked. That's the top 10 most populous countries in the world. I'm almost done now, but there's just one last thing that I want to sort out. The way these populations are displayed is horrible to read. The population of China is actually 1.4 billion, but what's being displayed here just looks like a mess of numbers. You have to really focus to work out what those populations are. And then look at India, 1 point something billion and 127 on the end. I'm pretty sure no one knows the population of India that accurately. So let's just clean up the formatting a bit. And that's where the last class in the project, Population Formatter, comes in. Let's take a look at it. The first method in this class, Format Population, is a method that I've written to format the population more neatly. I won't go over this code in detail because, to be honest, it's quite mathematical and it doesn't really have anything at all to do with collections. But if you're interested, it's available in the code download and fully commented. But what it does is first round the population to 4 significant figures and then add spaces to separate the thousands, millions and billions. By the way, I realise that there are some countries, including the UK where I live, where people tend to use commas, not spaces, but I've gone for spaces because people all over the world watch Pluralsight courses, and spaces are more widely recognised internationally. I'll go back to the main method and change the console.writeLine method to display rounded formatted numbers. The extra call to pad left, just right, justifies all the numbers at 15 characters, so they line up nicely, and I'll run that again. And yes, that's much better. It's the same data, but rounded, and now you can actually read it and understand it. No surprises that China is the biggest country in the world by population, with nearly 1.4 billion inhabitants, but I suspect it's less commonly known just how closely India follows it, with over 1.3 billion. And then the US is quite a long way behind, and my own native country, the United Kingdom, doesn't feature in the top 10 at all. Oh, I'm upset now. Before I finish the module, this is probably a good point to review how you declare and instantiate an array, because there are quite a few different ways you can do it, and you've now seen the most important ways in action. The simplest array declaration you've seen is this: array of countries equals null. And of course, that's not really instantiating an array at all. That's just declaring a variable and saying that this variable can, in principle, refer to an array of country. Arrays, by the way, are always reference types, even if the value they hold is a value type. So, for example, it's fine to say array of int numbers equals null, even though you can't say int number equals null. Int is a value type, and so cannot be null, but because an array of anything is a reference type, the array can always be null. The next step up is instantiating an array and saying how many values it must contain, but without actually specifying the values. As you saw earlier, if you do want to instantiate an array, this is the minimum information that you must provide. Arrays are always a fixed size, and that means that you can't create an array without saying how big it will be, how many elements it will hold. And recall that if you specify only the size, then all the elements of the array will start out at their default value. Country is a reference type, and the default value of any reference type is null. So this will be an array containing all nulls. If I did the same thing for an array of integers, it would be an array containing all zeros, because 0 is the default value for an integer. Obviously, when initializing an array this way, you'll invariably later on want to replace the zeros or nulls with the actual values that you intend to put in the array. And finally, you saw the most specific way of instantiating an array, in which the actual values are specified up front using a collection initializer. I should say there are a couple of variants of this syntax. In particular, provided the exact type is explicit on the left-hand side of the equals sign and there's a collection initializer present, you are allowed to omit repeating the array type on the right side of the equals sign, because you've still given the compiler all the information it needs to work out the type and instantiate the variable. That's quite a neat syntactic shortcut, although I should stress it only applies to arrays, not to any other collection. So in this module, I showed you an example of using an array in a more realistic app where we had to import external data into the array. Amongst the things you learned along the way are you can initialize an array without specifying the values to go in it up front, but in that case you must at least say how big the array will be. And in that case, the array will start life full of default values. You can use a for loop to populate an array with values, and you've also seen an example in the string.split method that points towards how .NET itself uses arrays extensively, so you will often encounter them even if you weren't intending to use them. I've spent a lot of time on arrays because they are the simplest of collections as well as being very useful in their own right. But in the next module, you'll encounter a situation in which arrays are inadequate, and that will lead us to your next collection type, the list.